Hello everyone, welcome to another series of CryptoZombies.io. We have already covered two lessons of Solidity Path. In this series, we are going to cover the lesson number 3, which is Advanced Solidity Concept. Let's start it. So, I just can't slow you down. Can I? Your Solidity skills are formidable, human. Now that you have got some experience coding Solidity under your belt, we are going to dive into some of the more technical aspects of Ethereum development. This lesson will be a bit less flashy, sorry, not plot twist, but you learn some really important concepts that will take you closer to building real DApps. Things like contract ownership, gas costs, code optimization, and security. You have been warned. No kitties and rainbows in lesson number 3, but a lot of densely packed solidity knowledge. We strongly recommend that you complete lesson 2 before starting this then. Okay, so let's get started. Chapter number 1, Immutability of Contracts. Up till now, Solidity has looked quite similar to other languages like JavaScript, but there are a number of ways that Ethereum DApps are actually quite different from normal applications. To start with, after you deploy a contract to Ethereum, it's immutable, which means that it can never be modified or uploaded again. The initial code you deploy to contract is there to stay permanently on the blockchain. This is one reason security is such a huge concern in Solidity. If there's a flaw in your contract code, there's no way for you to patch it later. You would have to tell your users to start using a different smart contract address that has the fix. But this is also a feature of smart contracts. The code is law. If you read the code of a smart contract and verify it, you can be sure that every time you call a function is going to do exactly what the code says it will do. No one can later change that function and give you unexpected results. So once we deploy smart contracts, we can't change it. As in a normal website or in a web 2, as we upload anything on our server, if we find any bug or any mistakes, then we can just update the files and re-upload them. But in a smart contract, you can't do that like that. You can't do that because whenever you upload your smart contract or deploy a smart contract on the network, it will give you an address, and that address will be used for your front-end application, and so the code will never be changed. And this is also a feature of smart contract because everyone knows what you have deployed, so everyone knows that they will not get an expected result next time because you will change it. You can't change it, so that's why always the smart contract will be the same. If you want to make change, you have to create a new smart contract and deploy it and use it in the DApp. So that's the basic concept of immutability. External dependencies. In lesson number 2, we hard coded the crypto kitties contract address into our DApp. But what would happen is if the crypto kitty contracts had a bug and someone destroy all the kitties. It's unlikely, but if this did happen, it would render our DApp completely useless. Our DApp would point to a hard-coded address that no longer returned any kitties. Our zombies would be unable to feed on kitties and would unable to modify our contract to fix. For this reason, it often makes sense to have a function that will allow you to update the key portion of the app. For example, instead of hard coding the crypto kitty's contact address into our D app, we should probably have a set kitty contact address function. Let us change the address in the future in case something happened to the CryptoKitties contract. So now let's do an exercise. Let's update our code from lesson number 2 to be able to change the CryptoKitties contract address. Delete the line code where we hard coded the secret address. Excuse me. Let's remove this line. Change the line where we created kitty contract to just declare the variable that is don't sell, set it equal to anything. Okay, create a kitty contract. There it is. Create a function called set kitty contract. Let's create a function. It takes two arguments, address, name it address, and sorry, it will take one argument. Okay, and it should be external function. External. Inside the function, add one line of code that sets kitty contract equal to kitty interface address. Let's add the line underscore address, this address. If you notice a security hole with the function, don't worry, we'll fix in the next chapter. Okay, let's see. Check the answer. Yes, this it's correct. So we have completed the chapter number 1 of lesson number 3. Now let's move on to the chapter number 2.